Hi, I'm Mark Breen. We've been looking at the movements and rhythms of the heavens, and we're going to continue that now with the moon. In some ways, I really like the idea of watching the moon. It's easy to do. Most anybody can do it, not hard to find in the sky, and yet there are a lot of different things that you can observe about the moon. So we're going to try to detail some of those, and we'll really start with where most science starts. We're going to start with observation, which you can go outside and look at. So that'll be kind of the focus, and we'll think about some of the different things. Maybe you obviously watched this moon, or you've seen the moon before. So we can think about what you've seen and maybe connect that with some of the different details about the moon in terms of its motion. It's, after all, kind of the theme here, the movements and the rhythms in the heavens. So we'll think about the moon's motion, both what we can observe and what the moon is actually doing and how that affects what we see out there. So in order to do that, we're going to get a kind of a look at what we can see. So we're going to take a look at this. All right, now let's just get that out of the way. And let's start with what you can go outside and see. So we've got a view here where we're looking at an evening sky. This is actually May 25th. And if you look over to the right, you can see the moon. And the X4 means the moon is 4 times larger than it actually appears in the sky. That's done for a couple of reasons. One, it does make it a little easier to see, but also there are actually some factors in your brain that make it look larger than it actually is in the sky. So in some ways, this actually makes it look more realistic. Now, we're going to get just a slightly closer view here so that you can see what we're looking at is a thin crescent moon. And that's kind of a nice view of the moon. Although, if you notice, you can see the entire moon. So this is, again, an observation type of thing as we look at the crescent moon. One of the things you can often see, especially about 3 to 4 days after what we call a new moon, and we'll talk about the phases as we go, but the idea here is that you can still see the night side of the moon. The lit part of the moon, the bright part of the moon, is where the sun is shining. So this is the night side of the moon. So think about that for a minute. If the sun is shining on the other side, what would be shining on the night side of the moon? Well, think about it this way. If you're on the moon and you're looking up into the sky, what would you see? Well, you're looking at the moon. So if you're on the moon, yes, you'd be looking at the Earth. And you'd be looking at the sunlit part of the Earth. So this is sometimes called earth shine. The Earth is reflecting light from the sun and shining it on the night side of the moon. So that's what actually illuminates it. And as long as the moon is a thin crescent, that continues to show up. As the moon grows larger and brighter, so to say, then its light kind of overwhelms the earth shine that you would see. So anyway, this is a good place to start. You can see the moon. It is a crescent moon. And since we're thinking about motion, let's think about that. Let's just kind of move out just a little bit in our view so that we can see the moon here. And I'm now going to let time start to go along. And where would you expect the moon to go? Just in terms of what we're looking at here, we're looking a little bit to the west and northwest. If we zoom out a little bit more, you can see west located here and northwest just on the edge of the image. So where's the moon going to go as we go into the evening? Well, if we move forward in time, you can see the moon starting to move. Is this moving the way you would expect? It is heading down toward the horizon. I don't suppose that's too much of a surprise. In general, that would be the east to west motion that we see for all the objects in the evening. But let me pause that and let's think about that for a moment. That motion isn't the moon. That motion, of course, is the Earth. This is one of the common themes that we've been talking about over the past few weeks, is that the Earth's motion spinning on its axis causes a lot of the motion that we see in the sky. It affects the stars and the planets, which we've talked about, and now, as you can see, it affects the moon as well. So the moon is appearing, let's call it that, appearing to move because the Earth is moving. So let's just bring the moon back to its position again, just a little bit earlier in the evening. The moon is a thin crescent. You can see some stars beginning to show up, and this is the evening view. Now, With that being the case, the moon moving just because the Earth is moving, let's take a look at the moon a night later, one night later. And as we do that, you can see the moon's position changes. So now we have the moon located actually closer to these two stars. And let's get it just a little bit later so we can see them just a little bit easier. The two stars we might as well identify. These are the two stars that we know as the twins. You can kind of see why. They almost look like twin stars, the star slightly brighter, but these two stars close together and fairly bright are the twins that we know as Gemini. So one of the things about the moon's motion, Gemini, perhaps you recognize, is one of the horoscope or zodiac constellations. The moon always travels through the zodiac constellations. Now the moon, I just said, is moving, and we did see it change in position. So let's watch it a couple more nights. Let's actually see it change over a few more nights. See the moon moving to the left and a little bit higher and closer to this star, which we can identify as the star Regulus. Regulus is the brightest star in the constellation Leo the Lion. Leo the Lion is another of the horoscope or zodiac constellations. So just another example of seeing the moon move. There are a few other things. Again, we're thinking about observation here. So what else do you observe about the moon and its changes over about 3 nights? Let's do this again so you get a chance to do just that. Let's see if we can observe the moon's changes over about 3 nights. So let's bring it back 3 days, 1, 2, and 3. Now the moon, a very thin crescent just above this tree, as it turns out. And you can see one of the stars of Gemini is now labeled. You can see Pollux showing up here, and the star that it was near before, Regulus, again, that is the brightest star in Leo the Lion. So there we see the moon. Let's watch it again. Motion taking place over 3 days. So 1 and 2 and 3. Do you see any change in the moon? Obviously, its position changed, but its shape changed a little bit, not a lot, but the moon is now larger. The crescent is growing, and this is what we call the phases of the moon. It starts out with a crescent moon, and you can see it's still a crescent shape, but it is somewhat larger. And so eventually, that's going to change. We're going to see that crescent get a little bit larger until the point where we can see about half of the moon. So let's do that. In order to keep our view here, we're going to change our view just slightly. We're looking a little bit more now toward the south. And we're also going to zoom out just a little bit so that we can keep the moon in view. And let's go forward a little bit more. Now the moon appears about half full. This half full moon, oddly enough, is called the quarter moon. Again, this is actually part of the moon's motion. The idea of the quarter moon often sometimes is interpreted as seeing actually physically 1/4 of the moon, and that is true. Of course, you can only see half of the moon. The other half is behind your view, so you can only see at a maximum half the moon. But in this particular case, this is not referring to the 25% of the moon's surface that you're viewing. Instead, the quarter moon is 1/4 of the way through its phases, through its cycle, as it's called. And so there we see the moon changing its position and changing its shape. Again, these are the phases of the moon. So let's continue on with this motion. We'll shift our view just a little bit more so that we're looking toward the south. And we don't need to see that, so we're just going to eliminate that. But let's go forward here. You can see the moon continuing to get larger, moving near the star Spica, and now growing a little bit larger. Past its quarter moon, you can see almost all of the moon. This is known as the Giveth Moon. Gibbous is actually a term that goes way back, but it means rounded or even humpback, sort of like a humpback whale with a curved back. So in this case, you can see the moon, instead of being kind of a straight line up and down where the shadows meet the light part of the moon. We now see it rounded, and so hence the name, the Giveth Moon. We'll let the moon continue on its progress. You can see it continuing to get larger, and we now get to a full moon. The moon is perfectly round, at least as we view it here. And so we've seen a series of changes, and let's kind of review those because there are two parts that we've seen change. We've seen the moon change its position in the sky, and we've seen it change its shape. So the phases of the moon are a little bit more involved. It's not just that the moon changes its shape, it changes where it appears in the evening sky. And that's what we've been looking at the evening sky. And so let's bring it all the way back. Let's just kind of shift our view so we can keep the moon just barely in view over here. And let's back up in time here. See the moon going backwards, getting smaller and smaller. And let's just kind of, I think it's just barely out of view here. Let's just kind of shift this and make our picture of the sky just a little bit larger. There we go. And there, we can just barely see the moon on the edge here. But let's take note of where it is. The moon is in the western sky as a thin crescent. And now let's go forward in time. As we do so, the moon, as it gets larger toward its first quarter, when it is half illuminated, is now more toward the south. And as it continues to get larger, going by the star Spica once again, as we saw before, we can now see the full moon appears on the eastern side of the sky, specifically SE, the southeast. And so the moon changes not only its shape, but its location during the evening. Now, this is something that obviously takes several days to take place, but this is a great thing that you can observe. So that's kind of observing project number one in this particular segment of the movements and rhythms of the heavens, is you can do this yourself. So on the next opportunity where you can see a crescent moon, then watch it over the next few nights as much as possible. Obviously, sometimes the weather interferes, but if you can track it over time, keep track of its location and its shape over a period of about 10 days to 2 weeks, and see if you can observe this same motion and change in its shape, going from west over to east and changing from a crescent moon to a full moon. One other aspect do we see, so we've seen the moon change its location, but this is part of the moon's motion. What motion would that be? Do you have a guess? I'll give you a second to think about that. The moon is actually moving. The moon goes around the Earth. So we're looking at the same time each night, and the Earth's spin on its axis will move the moon across the sky. Let's actually demonstrate that with this nearly full moon. We'll speed up time during the night. You can see the moon crossing the sky. But this, of course, is the Earth spinning on its axis. The other motion we've been observing is the moon orbiting the Earth. Now, of course, if it keeps going around the Earth and we're only looking in the evening, eventually the moon is going to disappear below the horizon. This is just another aspect of the moon and its motions and what you can see in the sky. We're going to discuss that in a little bit, but for right now, I want to think about sort of a different way of viewing this same idea. So we're going to use a different program to do that. We'll let this program just kind of slip down. And let's bring up this image here. In this case, and let's just take a view of the images. And so with a starry background, let's go forward. And now we can see a crescent moon. And again, kind of thinking of the sky looking toward the south, just as we just did. The crescent moon was over on the right side, which of course is west. As the moon grows larger, the moon shifts a bit more to the left. There it is in the south, a half moon, but again, we call that a quarter moon, a quarter of the way through its phases. As it gets larger and rounded, There is the gibbous moon. And then on the eastern side, on the left, we see the full moon. So looking at its phases changes its shape, and it changes where you see it at the same time during the evening. With the Earth spinning, of course, you're going to see the moon at a different location if you were looking at a different time of night. So these are the phases of the moon, but there is a little bit more to those phases. Of course, it has to do with the moon and the Earth and the sun and their relative positions to each other. So if you look in this diagram, you can see what we call the new moon directly between the Earth and the sun. That, of course, means the moon would be out during the daytime sky, and that means you're not going to see it. So one of the things about the new moon is it is sort of the invisible phase of the moon. Now, with the moon's motion, and in this particular case, it'll go counterclockwise, it moves to what we call a waxing crescent. That term, waxing, by the way, means growing or getting larger. And so a waxing moon is a growing moon, going from the slender, thin crescent to a larger moon. Again, its first quarter. You can see eventually it curves around to the waxing gibbous on the right, and then finally to a full moon. Now, these phases all have to do with where it's located relative to the Earth and the sun. So notice that the full moon is opposite the new moon. Instead of the moon between the Earth and the sun, the moon is now on the far side of the Earth relative to the sun. That means on the night side of the Earth, you're looking at the entire moon illuminated. Now let's talk about the phases that we haven't talked about yet. And these are what we know as the waning phases. Waning means getting smaller. And at first, the moon will be a little bit smaller, still rounded. Remember, rounded is gibbous, so a waning gibbous moon. As the moon gets smaller, eventually only half of it will be seen from here, the last quarter moon as it's called. We do eventually get to a waxing, or a waning rather, crescent moon. The moon, you would see mostly its night side with only a little bit of the daytime side viewable, and then it finally goes back to the new moon once again. So we watched that motion. We haven't talked too much about just how long that takes. We did note that it takes about 10 days to go from the crescent moon over to full, but the crescent moon isn't the beginning. Again, that's the new moon when you can't see it. So in entirety, the moon goes around the Earth from one phase, so let's say the new moon, to the next new moon. It takes 29.5 days. So that would be the orbit of the moon. That's its motion around the Earth. It comes around and goes through those same phases once every 29.5 days. So there are the phases as we would see it. Now, another way of thinking about that, thinking about these other phases, the waning phases that we haven't talked about yet. Now we're going to do this from the viewpoint of the Earth. So you can see the Earth in the middle, and you can see some hours noted around it. We'll make use of those as we think about these phases. So one thing that I want you to notice, in this view, it's a nice example of the fact that the moon is always illuminated halfway. Of course, the sun is only shining on one half of it, just like the Earth. In this case, it is our view relative to where the moon is that gives it its changing shapes. So as we look at the waxing crescent, which is on the upper right, you can see mostly the Earth will be looking at the night side of the moon, just a little bit of the daytime side. Now notice that that has 3 o'clock aimed in that direction. And in fact, we can bring that waxing crescent moon there. That would be the time when you can see the moon in the south. So you would see the waxing moon in the south at 3 o'clock in the afternoon. Of course, that means the sun would be up. And indeed, at about mid-afternoon or so, with a waxing crescent moon, you can see it in the daytime sky. Now, as we get to 6 o'clock, we can see the first quarter moon at the top of our view. And let's bring that first quarter moon up into view. And so it's 6 o'clock. So approximately sunset, you can see that moon. It would be in the south. You can see it about half full. As the moon becomes a waxing gibbous moon, now the moon would either be to the left, we saw this earlier, or you can think about it as being in the south at around 9 o'clock. So after sunset, you would see that moon shift because of the Earth's spin on its axis, so that you would see it in the south around 9 o'clock. And finally, notice the full moon is lined up with midnight. The moon is full and directly in the south at about midnight. And there's the full moon. Of course, past the full moon, the moon will not be in the sky during the evening. So let's think about evening as approximately 6 o'clock. If you're looking at the waxing or the waning gibbous moon, which is on the lower left, notice that if you're at the 6 o'clock position near the top of the Earth as is imaged here, you can't see the waning gibbous moon because the Earth is in the way. You would have to wait later at night for the waning gibbous moon to appear. So that will be one way to think about this time dial that we have on here, is you would see the waning gibbous moon rise later at night. There's the waning gibbous moon. The third quarter moon would come up even later at night. And then finally, the waning crescent moon appears in the early morning skies. So we've talked about that, and we can sort of see the image of it here. Let's actually show you that using the Stellarium program so that you can see how the moon would change later at night. So we've gone back to this view of the moon. Now we allowed the moon to move a little bit, so we're going to shift that moon. This is the full moon, so we're going to bring it back time-wise. So we're going to go backwards in time. We're going to bring the moon over toward the horizon. And we'll also shift our view a little bit toward the eastern horizon so we can see the moon where it's about to rise. Let's actually pause it right here. One other thing, notice the sky's gotten a little bit brighter. The full moon, as you saw in the other diagram, and maybe we can even bring that back up here for just a moment. The moon, when it is full, is on the opposite side of the Earth. So let's just kind of take a look at this image here. You can see the full moon is located opposite from the sun in the sky. So think about that. At sunset, the moon would be on the opposite side of the sky, so the moon would be coming up as the sun would be setting. So, as our view here, let's get back to Stellarium, the moon is coming up as the sun is setting. That's why there's a bit of a glow still in the sky. Now, if we go one night past the full moon, let's see where the moon is located. I don't see the moon. That's because the moon continues its motion, which is going this way. It is dropped below the horizon. So let's see if we can't get it a little bit later at night and let that moon rise. There it is. It comes back into view, of course. And if we let it climb a little bit higher and we go forward in days, you can see again the moon's coming up later at night. Time-wise, it is now midnight. We don't see the moon. The moon won't be rising until after midnight at this point. And there you can see the moon coming up. Now, usually when the moon is rising near midnight, we get to its last quarter phase. And you can see the moon does look about half illuminated. Now, in the early morning skies, and again, we're going to let the sky move a little bit here. We're going to let the Earth spin so that it's a little bit later at night. And we'll let just a little glow of sunlight come in there. Forward in time, you can see the moon's getting thinner as a crescent moon. So you would see the crescent moon in the eastern skies just before the sun comes up. So that's where we would see the other phases of the moon. So sometimes if you don't see the moon out in the evening sky, it's not that the moon has obviously disappeared. It is past its full moon phase and will be showing up in the early morning hours. One other thing to consider, since we've been talking about the moon in orbit, we can also demonstrate that during the night, during a single evening, you can also watch the moon's motion. Now, this is a little trickier, and it often involves finding just the right time. So we've got a different view using Stellarium again. But in this case, we've picked out a date. This is back in January of 2020, with the moon located near the star Regulus. We identified Regulus earlier as the brightest star in Leo the Lion. I've also got a grid image here, and this is the grid of the sky. So in other words, this is how we locate various objects in the sky, much like we have the latitude and longitude lines on the Earth if you're thinking about the globe. But what I want you to note is the position of Regulus, which will not change relative to this grid. But the moon is in motion. And notice this blue line located right here. And let's watch the moon during the course of the night, and let's keep track of that line. So we're going to go forward in time. You can see time's now slowly speeding up. So as we watch the moon obviously appears to be going east to west, much like all the objects. But if we pay particular attention to that blue line, if you'll notice right now, you can see the moon is actually crossing that line and shifting to the other side of it. The moon is moving. And although we see it moving basically from left to right, and let's kind of pause that here for a moment, the moon's actual motion relative to all the stars, so its motion in the actual sky, is shifting it to the left or east. So the moon's true motion in the sky is not east to west, but west to east. It takes, as we talked about just a moment ago, the moon takes 29.5 days to go around the sun, or go around the Earth rather, one time. As the moon orbits the Earth in 29.5 days, that is much, much slower than the Earth's spin on its axis. That only takes 24 hours. And that's why the moon appears to go from east to west when its actual motion is from west to east. We're spinning much faster than the Earth is moving, or than the moon is moving in the skies going around the Earth. So this is just another way of seeing an example of that. Having a bright star like Regulus gives you an opportunity to see that motion. Say if you were to watch it at the beginning of the night, early on, and then maybe you'd get up just before sunrise and see where the moon is located relative to the same star. You'd be able to notice its change. Now, we've talked about this in terms of how we can view it. But of course, the moon's actual motion in the solar system is a kind of a different view of that. So we're going to change our program here. We are going to use another program that we've been using, featuring, and that's Celestia. And so in this view, we're now looking at the moon a little bit closer. You can see we're looking at the night side of the moon, but we've added a few things. We have the moon, the Earth is where you are, so you're looking at the moon, and you can see the sun in the distance over on the left-hand side. The red line represents the moon's orbit going around the Earth. Now, in this particular view, and we're going to speed up time, you're going to be able to see the moon and its phases, but in this case, we're going to stay looking at the moon. So this is a view from the Earth looking at the moon with the sun basically changing its location. We're going to watch, we're going to stay focused on the moon during its orbit around the Earth. And that means we're going to see its phases. So let's get time. Whoa, hang on a second here. We've sped up time a little too quickly, but that's all right. We'll just let it slow down here. Now, we're watching the moon. We can see it as we see it from the Earth, and you can see it changing. In fact, the moon's getting smaller now. You, of course, know that means the sun's coming by. There's the sun going by to the left, and now you can see, and we'll see this a little bit easier here, the moon's growing. It's about half full. The moon continues to grow into its gibbous phase, and eventually its full moon. Now, the moon will start shrinking. You can see the change as it goes back to its last quarter, then a crescent moon, and then you can anticipate the sun will be coming by once again. So we're now looking at the night side of the moon. But there's one more thing to observe here. Notice that as the moon becomes more illuminated, you're looking from the Earth toward the moon, we are seeing only one side of the moon. The moon's not moving around, it's not spinning around. One of the curious things about the moon and its motion around the Earth is no matter where the moon is in its orbit around the Earth, the same side of the moon is always facing the Earth. Now, technically speaking, that means the moon is spinning, but it's spinning at the same rate that it's going around the Earth, leaving one face of the moon always toward the Earth. One thing to think about, there is a phrase, the dark side of the moon, but the dark side of the moon changes. One thing that doesn't change is the far side of the moon. We never see the other side of the moon from the Earth. That wasn't accomplished until spacecraft started going out and around the Earth in the 1960s with the Apollo mission. So this changed how we understood the moon. We knew that it was there. We didn't know what it looked like, but we had a chance to see it once those spacecraft started orbiting behind the moon. So these are the basic motions of the moon. Now we're going to advance in our next segment, talking a little bit more about some of the fussier details about the moon's motion. It changes its path in the sky during the different months of the year. The moon does not always appear in the same location. So we'll talk about that. We'll also talk about the fact that with the moon going between the sun and the Earth every month, we don't get an eclipse every month. So we'll have to think about that as well. So these are the upcoming subjects that we'll deal with on the next Movements and Rhythms of the Heavens.